Okay, now we're going to learn about Newton's third law of motion. So learning target 16 still, you're going to be able to apply Newton's third law and draw action-reaction diagrams. Okay, this is probably the law that you've heard the most. Forces act in equal but opposite directions. For every action, there is an equal but opposite reaction. So Newton's third law talks about action-reaction force pairs. These force pairs do not cancel each other out because each force is acting on a different object. Here's Newton's third law of poker. For every action, there is an equal and opposite reaction. Thought that was kind of cute. They have a lot of cute comics for Newton's laws of motions. See, here's another one. Forces come in pairs. That's adorable. Okay, so let's look at some examples. And don't make fun of my drawings. You know I'm not an artist. Okay, so this is a bird. Yes, it's a bird flying. Okay, so whenever we have something that's in motion, we have action-reaction force pairs. So when the bird is flying, the action force is the wings that push down on the air. The reaction force is the air pushing up on the wings. So that's where the statement comes in. For every action, there's an equal but opposite reaction. Notice both of these forces are equal in opposite directions. However, they're acting on different objects, so they don't cancel each other out. And that's why the bird is still moving, because this is not a balanced force, because they're not acting on the same object. The action force is the wing acting on the air. Once the wing acts on the air, then the air pushes up on the wing. This happens one after the other. So that's an example of an action-reaction force pair. Okay, some other examples. A rocket ship taking off, the action force is the weight of the rocket plus the air friction equals, so the weight pressures, the weight of the, I can't talk today, sorry, the weight of the rocket presses on the air, and the air pushes back up on the rocket, which is called thrust. So there's your action force, reaction force. They are equal, but they don't act on the same object, so that's why the rocket goes. And I found this picture on there, and I have no idea why it's a ghost on a skateboard, but it works. The action force is the person pressing on the wall. Then the wall also presses back on the person, and that's what causes the motion. Action, reaction. Okay, so when we talk about action-reaction forces, we can actually get to something called weightlessness. Your weight pushes down the scale. The scale pushes back with equal force, and that's why when you step on a scale, it gives you your weight. However, if you took that scale, and you can actually do this, take your scale, go to an elevator, and have the elevator go down. Only gravity is the force pulling on the elevator. So the scale will actually record a weight of 0. So if you want to really lose some weight, just take your scale down on the elevator and it will record nothing. You really won't have. It will just show weightlessness because there is no force of the scale pushing on you because you're just pulling down on the elevator. So that's considered what we call free fall. You're not really weightless, there's just no record of it. You have to have the force, the reaction force. You have to have a way of measuring that, and the scale can't do that. So this is why when you're in space, the space shuttles in space, they're all in free fall. But instead of falling down, the force of gravity curves it, so you float. So normally, a man's mass exerts a force on Earth. The ground exerts an equal but in opposite direction force on you. When you're in free fall, okay, the only force that's acting on you right now is gravity. There's nothing pushing back on you, so that's why you feel weightless when you fall. Hopefully that doesn't happen very often. Okay, so hopefully after listening to these notes, you are going to be able to draw action-reaction diagrams, label them with the arrows going the correct direction, label them action and reaction, and identify what those are.